Every time you make a database call from your application, you trust that the database driver does exactly what you told it to do. But what if you needed to log every call, measure its duration, cache the result, or enforce access rules without modifying the database driver itself? This is precisely what the proxy pattern enables, intercepting and controlling access to another object. A proxy sits between the caller and the real subject. It has the same interface as the subject, so callers treat it identically, but it can intercept any operation, add behavior, and then delegate to the real object. The key characteristic is interface transparency. The proxy and the subject look identical from the outside. A caller using a proxy doesn't know they're talking to a proxy. They call the same methods with the same signatures. This is what distinguishes a proxy from a wrapper that changes the interface. A proxy preserves the interface exactly. Why does this matter? Because it means you can swap a proxy in for the real object anywhere in a codebase without changing any of the code that uses it. Add logging to a database client, create a logging proxy, pass it to the service instead of the real client. The service never changes. The logging proxy transparently records every call and passes it through. This sounds simple, but it's the basis for some of the most powerful patterns in software engineering: caching layers, lazy initialization, access control, validation, monitoring, virtual objects that load data on demand. In Node.js, there are three main techniques for implementing proxies: object composition, object augmentation, and the built-in ES 2015 proxy object. Each has different trade-offs. Understanding all three lets you choose the right tool for the situation. The first technique is object composition. You create a new object with the same interface as the subject. Every method on the proxy calls the corresponding method on the real subject, with whatever additional behavior you need before or after. The proxy holds a reference to the real object but is otherwise independent. The advantage: complete control over which methods to intercept and what to do. The disadvantage: you must manually implement every method in the interface. If the subject has 20 methods and you only care about logging 2 of them, you still have to write 18 pass-through methods. It's verbose, and if the subject's interface changes, you have to update the proxy too. The second technique is object augmentation, also called monkey patching. Instead of creating a new object, you modify the original object directly, replacing methods with new versions that add behavior before calling the original. You store a reference to the original method, replace it with your wrapper, and call the original inside the wrapper. The advantage: concise, you only write the methods you want to intercept. The disadvantage: you're mutating the original object, which can be unexpected and difficult to undo. It's generally considered bad practice because it violates the principle of least surprise. The third technique is the ES 2015 built-in proxy object. You create a proxy with a handler object that defines traps, interceptors for any property access, function call, property set, or other operation. Unlike composition, a proxy with a get trap automatically intercepts all property accesses, not just the ones you explicitly coded for. This is metaprogramming. The built-in proxy is the most powerful approach. You can intercept operations you couldn't even anticipate at proxy creation time. The trade-off is that proxies have some performance overhead and are harder to reason about. To make these techniques concrete, the book builds a logging proxy around a writable stream. The goal: intercept the right method to log every chunk of data written, without modifying the underlying stream. Using object composition, you create a new object with a write method. When write is called, the proxy logs the chunk size and content, then calls subject.write, with the original arguments and returns the result. For other methods: end, on, once, emit, you delegate directly without interception. The proxy object implements the full writable interface. But here's the problem: writable streams have many methods inherited from event emitter and the stream base classes. Writing a full composition proxy requires implementing all of them. The proxy becomes a lengthy but mostly mechanical file. The built-in proxy object handles this elegantly. You create a proxy around the stream with a get trap. The get trap intercepts every property access. If the property name is right, you return your logging wrapper. For everything else, you return the original property from the subject. This way, all the methods you don't care about work exactly as if there's no proxy at all, automatically, without any code. Const logging proxy equals new proxy, stream, get, target, property, if, property equals write, return function, chunk, args, console.log, writing, chunk.length, bytes, return target.write, chunk, args, return target, property. Now logging proxy has every property and method of the original stream. The only one with added behavior is write. This is why the built-in proxy is so powerful for cross-cutting concerns. You intercept exactly what you need and everything else passes through automatically. One of the most compelling uses of the ES 2015 proxy is building reactive objects that notify observers whenever any property changes. This is a foundational technique used in virtually every JavaScript reactivity system. The idea: wrap any plain object in a proxy with a set trap. Whenever a property is written, regardless of which property, the trap fires. You record the change, notify any registered observers, then actually perform the write on the original object. A simple change observer, const observed equals create observable, original object, prop, value, equals, console.log. Now whenever you write observed.name equals Alice, the callback fires with name and Alice before the assignment completes. The original object is updated, observers are notified, all transparently. This is exactly how Vue.js3's reactivity system works under the hood. Vue wraps component data in proxy objects with get and set traps. The get trap tracks which component is reading the property, establishing a subscription. The set trap notifies all subscribers, triggering re-renders. The framework automatically discovers dependencies just by observing which properties the render function accesses. Mongoose, the MongoDB object modeling library, uses a similar mechanism. When you access a field on a Mongoose document, the proxy's get trap can intercept the access for schema validation and type coercion. When you set a field, the set trap can mark the document as modified for the next save operation. This is metaprogramming, writing code that reacts to the structure of objects, not just their values. The proxy object is what makes this possible in JavaScript without any framework magic. Having explored the mechanics in two implementation examples, let's look at where proxies appear in production Node.js and how they shape the libraries you use every day. Mongoose, the most popular MongoDB ODM for Node.js, uses proxy-like mechanisms throughout its document handling. When you define a schema and create a model, Mongoose instruments the resulting objects so that property accesses go through validation, type coercion, and change tracking. Accessing a number field on a document returns the value cast to the right type. Setting a required field validates it against the schema rules. All of this is transparent to application code. The Immer library, widely used in the React ecosystem, uses ES 2015 proxies to implement structural sharing for immutable updates. You call produce, state, draft equals, draft.user.name equals Alice. Inside the callback, draft is a proxy. Every write you make to the draft is recorded as a set of changes. When your callback returns, Immer replays those changes against the original state structure, creating a new immutable state with only the changed parts replaced. The original state is never modified. The proxy makes the mutation-style API possible while preserving immutability. In test frameworks, proxy-like patterns appear in mock objects. When you create a mock and call methods on it, something is intercepting those calls, recording the arguments, and returning configured responses. That interception mechanism is often built on proxies. The common thread: a proxy is the right tool whenever you need to intercept operations on an existing object without modifying it or its callers. It's the pattern of choice for cross-cutting concerns that operate at the object access level.